Hi, I'm Jeff Yee, and welcome to the last, video number 9, in the Particles of the Universe video series. And this one's a summary. It's a summary of all the videos you've seen so far. And I've started each of those videos with a question. Now, those started with science questions, and this one's a little bit different. This one is a question for the next generation, which is now that we have a new theory that can explain things that were previously unanswered in science, and it can also stand the test of math. The question for you is this: what are you going to do with that knowledge that will help to make this world a better place? So here we are, finally, a summary now of everything that you've seen in the first 8 videos. And the way that this summary is presented is in 3 parts. Logical, explaining particles and forces and energy, the simplicity of the theory, and finally the proof that was provided in the first 8 videos. The bulk of this will be in the first section, which is logically explaining everything in the first 8 videos. But I love this quote that you see there. Yes, everything is simple. It's people who complicate things. And you're going to see that as we get to the simplicity of this theory. I'm going to start first with the logical definition of particles and photons and forces. And in some ways I wish I had started with this at the very beginning, but because there are some things that are truly different from the current interpretation in physics, that it required step-by-step proof, which was walked through in the first 8 videos. But here's now is a logical summary. And the first video started with energy, and it had to because we needed to describe what it is. And energy is the motion of the ether flowing as wavelets. Now, energy may transfer forms. We walk through longitudinal waves and longitudinal standing waves, which is particle energy, and transverse waves, photons. But it's always conserved and can be calculated based on wave properties that you see here: density, volume, speed, wavelength, and amplitude. And in fact, even the forces were derived from this as well. Let's start first with particles. Particles are created from longitudinal standing waves in this theory. Now you can see this represented as the motion of these particles. The blue lines that you see there are just representative. It's a sine wave, so we can represent a longitudinal wave, which is very difficult to show. So you'll see that throughout the summary as blue sine waves. Those are meant to represent longitudinal waves, just like this. So a wave center now reflects this energy, creating a standing wave, right? It's a combination of an in wave and an out wave. That is what forms standing waves. And the radius of a particle is now where it transitions back to traveling waves. Now, based on the predicted energy of a fundamental particle at 2.39 electron volts, it is possible that the neutrino is the fundamental particle, but throughout these videos it was just referred to as a wave center. And a fundamental force, right? Wave centers move to minimize amplitude, and it's the cause not only of particle creation, but it's actually the cause of all forces as well. So there is really only one fundamental rule here for force. Now, with a standing wave, they're different. A standing wave, the nodes are the point of minimal amplitude, and that's illustrated here where red just signifies just the color here means that the wave center is not at the node, so black is when it's at the node. And so that is the position where there would be minimal amplitude within a standing wave. And again, a standing wave is created from a combination of an in wave and an out wave. But beyond that, beyond a particle's radius, where it is a traveling wave, it still follows the fundamental rule to minimize wave amplitude, but there is no standing wave node. It will continue until the point where it reaches a minimal amplitude. So again, one fundamental rule, but based on these 2 different types of forms of wave, standing versus traveling, you have 2 different types of results that you see. Particle energy. When wave centers combine at standing wave nodes, wave amplitude, again, here's the representative of the longitudinal standing wave energy, wave amplitude increases proportional to the number of wave centers. And not only that, but also the number of wavelengths, which affects what the particle radius, increases proportional to the amount of wave centers that are in the combination particle. And the particle's rest energy is calculated as all that standing wave energy. Again, standing longitudinal energy is stored mass, or stored energy. And that is sort of the definition of mass. It's stored until it can be released. And it was calculated for all the particles based on the equation that you see here. And the variable in there is k. K represents the number of wave centers. And you can go back to the video on particles if you want to see how this was used to map the energy of all the particles. But logically, this explains both the creation and decay of particles. Now, in nature, which is going to be lower energies compared to what happens at particle accelerators like CERN, but this is seen in neutrino oscillation. As neutrinos come from the sun to Earth, it's called oscillation, where they can form larger neutrinos. Well, how? That's never been explained, but here this model makes a lot of sense. As they combine, they can create new particles. And what is also seen in particle accelerator labs here on Earth is at higher energies now, more wave centers might combine, and these create very heavy particles. And the more energy that's thrown at this, the heavier the particles. Well, that's because there's more wave centers combining. But particle decay, all of these wave centers cannot be placed at standing wave nodes. Get into the geometry of that in a little bit, but they have to be at wavelengths, and they have to be at wavelengths at three-dimensional directions. And so red again here is just representing that wave center is not at a node. And when this happens, again, the fundamental rule for force says that it has to move until the point where it's minimized its wave amplitude. And so it'll continue to break up until the point where it is stable and that those wave centers are on the nodes, creating the stable particles. So again, a logical definition of a fundamental particle explains the creation and decay of the particles that we see. Now the electron is one of the most stable particles that there is. And what's interesting in doing the calculations is that the value k, and going back to that equation a few pages ago, value k was 10 to match the energy of the electron. Now this is hypothesized, but it could be a 3-level tetrahedron. And this is why. And a 3-level tetrahedron, by the way, has 10 units, so k equals 10. Now, waves are coming from all different directions, but depending on the way that these waves are coming, most of these wave centers are going to be at nodes. So as you see there, as a longitudinal wave hits from this direction as it hits, most of these are at the node, but with the exception of one. I'm just going to color this one red again. So it's not on a node, and so therefore, fundamental rule for force, it will minimize amplitude, and so it will move to a node. And when that happens, it's going to kick another one off the node. And it's this continual process now of requiring energy, because as one wave center moves to the node, another one is now off. And it creates this interesting spin of the tetrahedron particle. And furthermore, because of the geometry, it's not a sphere, it's a tetrahedron that's spinning. It requires 2 rotations to get back to original position, otherwise known as half spin. And so what's happening is longitudinal wave energy is being absorbed, and it's being absorbed by the wave center that needs to move to the node. And that new energy is creating a spin wave. It's called a transverse wave, and that's the basis for magnetism. Now speaking of magnetism, we're going to get into the forces here. So the electric force is the fundamental force. I'll explain why in a second, but longitudinal waves are reflecting off of wave centers, and they combine via constructive wave interference. By the way, this happens all the time and can be modeled in real-world systems, sound waves, for example. And so as a wave bounces off a wave center, it is now adding to the waves that were already continuing that direction, and so it increases amplitude for particles that are in the same phase. Now, particles that are in the same phase now have constructive wave interference, increasing the amplitude, and it forces them away because of the rule of moving in the direction of minimal wave amplitude. So particles that are in the same wave phase are constructive, and it causes them to be forced away. Now, similarly, a destructive wave interference happens for particles that are antiphase. An antiphase is 180-degree phase shift. And at this point of the wave, as it reflects, it will now be destructive with the waves that are also continuing that direction. So it's completely destructive, and it causes this, which you see there, which is an annihilation of these particles. So in this case, this would be an electron and a positron. That's the electric force, and that's because it's just what's happening with longitudinal waves being reflected off of wave centers. Magnetism will also have that same property of constructive and destructive wave interference. As mentioned earlier, the electron is spinning, and there's two different ways that it can spin. Just call it counterclockwise and clockwise. Now, for same spin particles, that same magnetic wave now, that transverse, or call it a spin wave if you will, would be constructive between the particles, forcing it away. And likewise, two opposite spin particles can be destructive. Now, in the absence of any other force, because keep in mind there's also the electric force, but in the absence of any other force, such as when atoms where they would be neutralized, destructive waves for the transverse wave would do something like this for opposite spin particles. Again, so it's just the property of waves and either constructive or destructive wave interference with the same rule that the wave centers will move to minimize their amplitude. Now gravity. Gravity gets a little bit trickier. But if you consider the longitudinal wave energy, again, approaching from all different directions, and this is just this, called the standard wave, which is longitudinal traveling waves. Using the conservation of energy principle, the in wave is equal to two out waves now, because you have one, what was magnetism, as the wave center moves to minimize its node, minimize wave amplitude and moves to a node, it creates that magnetic spin wave. And then the remainder of the energy being reflected by all the wave centers is the longitudinal out wave. Now, using conservation of energy, it has to be less. But it's just barely, in the calculations that were given in the video on forces, and if you go back to the book, the details are in there. It's a very, very small amplitude. Again, we're using sine waves here, and in just one direction. This is going to be coming from all different directions for longitudinal waves. But just to illustrate this, going from left to right, that the longitudinal wave represented in sinusoidal waveform here, that amplitude difference is small. Now, that amplitude loss is irrelevant because for two particles, constructive wave interference, the electric force adds or subtracts so much more than that tiny little gravitational amplitude loss. So two particles will always, like electrons, will always repel. But for an atom, it's different. An atom contains a proton and electron that have destructive waves, right? So they've been neutralized. And so now the amplitude loss becomes relevant again. But it's still incredibly tiny, right? It's really not going to do that much. It will be attracted, but it's incredibly small. But as you add up the difference now, when you include multiple atoms, that loss of amplitude starts to become significant. And when you get to a large body such as Earth, now you have enough of an amplitude loss that it is attracting particles. And that's gravity. Now, lastly, the strong force. Strong force is still the same property of standing waves and being placed at nodes. Now typically, and these are two electrons will repel. But again, if you use the rule of minimizing wave amplitude, let's just say you have a force that's so great that it is greater on the external side, applying it to so that the wave amplitude is pushing two electrons together. Now they could be pushed to the point where they are on standing wave nodes, again because it is minimal wave amplitude, right? It fits within the rule. And when they are pushed together, they create basically a new particle, just like we saw with earlier with combination of particles like neutrino oscillation. Now the electrons are actually very stable particles, so they would probably still continue in form in geometric arrangement, but it's now a composite particle, and the spin, the required energy that it takes to spin is much more significant. And so that was calculated as a change in wave amplitude using the fine structure constant, and it's the strong force known as a gluon. But this would only be stable in just one dimension, one direction, because just like what we saw with the electron, it requires wave centers in basically a stable three-dimensional arrangement. And so what it requires are two more electrons at the same time that are all pushed together to be able to have that stability. And now you've got the structure of what becomes a nucleon. And even though you can't see there's in the back there, in sort of grayish, is the back of the tetrahedron. So you've got four arranged as a tetrahedron. Okay. Now that'd be an empty nucleon. Now a positron could be attracted to and conveniently located here in the center. Seems strange, right? Because protons today are considered to be three quarks, but in 2015 something called the pentaquark was discovered, where it is four quarks and one antiquark. And that's exactly what we see here. There's called four electrons in a positron, but the electron was modeled as really just a highly energetic, sorry, quark was modeled as a highly energetic electron, and the antiquark is a highly energetic positron. And so that is what was found recently, is the pentaquark. And it has a positive charge due to the positron being in the middle. The electrons at the vertices are spinning and taking that energy and creating the gluon. We're going to see that later in orbitals. And so a neutron can also be explained, right? The center center positron can attract an electron. It is now destructive waves, therefore it is neutral. And that becomes a neutron. Again, this is very, very different than the current interpretation of what a proton and neutron is, but not only was a pentaquark found recently at CERN, but beta decay results for a good century or so can now be explained by this. A neutrino with sufficient energy, right? It has kinetic energy as it's traveling from the sun, for example, can hit that center electron and dislodge it. And this is what is seen in beta decay results. As a neutron transforms to a proton, an electron and a neutrino are found. Again, it's not a quark. A quark is not found in beta decay, so a proton and a neutron should never have been described as quark to begin with. And likewise, another beta decay experiment is that a solar neutrino can dislodge, probably takes more energy, can dislodge the positron now from the center. And now it's the empty nucleon, which by the way is going to have a neutral charge again, and that's exactly what appears in beta decay experiments. Now this arrangement, this neutron, could still appear like a neutron, but this is not the one that would be stable as we get into atomic element formation, so this would be a free neutron. Now we're going to have to shrink this a little bit more. We need more space, that's why that proton just got smaller, but it is still the same proton. But we're going to talk about photons next, right? Because photons are responsible for light and everything in the electromagnetic wave, from radio waves to gamma waves. And it's really just a vibrating particle. And a photon's energy was also calculated, similar to particles. It has its own equation, and it was expressed as the following. But really the cool part about it was being able to show mathematically the conservation of energy, and that's always equal and conserved. And it simply just changes waveforms. The calculations of photons being created from atoms, and also from the annihilation process of particles, and also the photon being used for the creation of pair production, an electron and a positron, were all based on this rule, the conservation of energy, where the transverse energy is equal to half of the longitudinal energy, or the change of it, and half because there were two photons that were created. And all of this was proven, and it'll be shown again at the very end of this video, but it's in the video on photons. It's really amazing to be able to calculate the energy of an electron being captured as a change in destructive longitudinal wave energy is just transformed. All it is a transformation of wave energy from longitudinal to transverse. And that electron that was being captured on that previous slide is not annihilating with the proton like it would with a positron. And it is true that the electron would be attracted to the positron, and it would be attracted to the positron in the center of this proton from any angle. And that's the key. But at certain alignments, right, the strong force there in the proton, where these electrons are at the vertices, and they were spinning and they had that new transverse wave. Well, that transverse wave is attractive within the particle's radius because they're being placed at standing wave nodes. Again, that is still within the fundamental rule for forces, which is minimizing wave amplitude, and it's because it's at a standing wave node. But beyond that, again, traveling waves now, and it is repelling. But it's only on that axis that it is repelling, and it's repelling at the cube of distance, whereas the attractive force is at the square of distance. And there's that repelling, and it's repelling only on these axes. And so an orbital for an electron was accurately modeled such as this. It's being attracted, and it's being repelled at the same time. And when you plot that, and you map it, you know, the electron is described as being almost anywhere, and it has a probability. But here in this theory, it can be calculated using classical equations, because the most probable location is where the sum of the forces is 0, and that's how the orbital distances were calculated. And yes, it does have a probability, but, but it's only because we don't know and understand where that atom is spinning and calculating each of those at the same time. And if we had that data, and if we could, then we would know the electron's position at any time. But here's the really interesting thing about it, and what validates this even further. Even though the electron has a probable location, it always has the orbital the wavelengths that are seen in the spectroscopy results are always the same wavelength when it comes out of a certain orbital. It is fixed, and it is fixed because that attractive property is always the same. It's probable, or appears to be probable, because as the proton spins, it has to match the certain alignment of the tetrahedral vertices where it repels, and that's why. Now, as you add more protons, the distances and the shapes begin to change, and that also can be explained here with the pentaquark structure. And the pentaquark structure of the proton is amazing because it will not only explain the distances, but also the shapes and the very last part of this, the periodic table of elements and the sequence of atomic elements. Let's take this one step at a time first. And we're going to need a little bit more space. We're going to shrink this down again. Let's start first with hydrogen. Okay. Now, as we add two neutrons and another proton and another electron, that is helium. Now, for simplicity, because these diagrams are going to get very complex, neutrons are needed to separate protons, but they're going to be removed. So you saw that yellow is just removed. We're going to assume the spacing between these protons and neutrons will not be shown. Now, orbital distances change as more protons are added, and there's more an attractive force. But at the same time, we have more electrons, and they will cause forces on the others, and becomes much more complex now to determine the point at which the sum of the forces is zero. Now, individual protons are spinning within the nucleus, and for helium, they're spinning in separate directions. And until boron, it'll be a planar geometry, meaning a two-dimensional plane. And when a third proton is added for lithium, this is the first time now that there are two protons that have the same spin in a nucleus. Now you see there the vertices are aligned such that now a wave passing through that direction, passing directly through the vertices of both of those same spin protons, is now repelling even further. All the way around, all of this will always have the same attractive properties of 3 positrons from this nucleus, but in a line here, there will be a stronger repelling force that causes the second orbital. And until boron, these shapes are spherical. Right? And that's known as the s orbital shape. And until boron, you've got 2. You've got one inner one and 2. And you've got potentially 2 electrons that will fill the outer 2s. But beginning with boron, and boron has 5 protons, and I've modeled this up to neon, which is 10 protons. Protons now align in a 3D geometric shape. Not surprisingly, again, another tetrahedral arrangement appears. Why? Because it's for wave stability. And the entire nucleus is spinning. And I wish my animation techniques were good enough so that I could show both this spinning all at the same time, but the protons are spinning at the same time the nucleus is spinning. And so I will just use arrows because it's easier to show, but the entire thing is spinning while protons individually spin in there. Now, as it spins, you can see there's the electrons, and as it's spinning now, there are times when the opposite spin proton will align the vertices with the same spin protons. But because of the way that everything is spinning, the 2 individual protons in this case that are spinning opposite of that last one at the very bottom are spinning along with the entire nucleus, there is essentially 2 points within the rotation where everything aligns. And what it's doing is it forced out the electron to be much, much further than 2s. And so what happens is it looks like a sphere, but it's now cut in half. And that's exactly what the p orbital shape is. It's essentially a sphere, but with the third row of a tetrahedron with an opposite spin proton, it's aligning or cutting, if you will, a point where the electron is forced out further. Again, all of this can be modeled with classical physics equations. And another row now in the tetrahedron allows the electron to be pushed out even further to the third orbital now, but also it will have another opportunity as it rotates, the entire nucleus rotates, to be cut yet again. And this is the d orbital. And the d orbital would also be a sphere, but yet it's now cut 4 times instead of 2 times, just because of the rotation and the extra proton. And the same, oh sorry, one more thing. The d orbital also has a unique shape here. And that's because if you look at a 4-level tetrahedron, there is one proton that's not on the face. It's at the very center of the bottom row of a tetrahedron. And that results in one d orbital that has a unique shape. This doesn't have the clover pattern like the other one does. And moving on to the f orbital, it's exactly the same. Now you add another row in the tetrahedron there, And with 5 protons on the faces, these are the ones on the faces that have alignment, it gets pushed out to the 4th orbital. But as it rotates, it now cuts it an extra 2 times, and so now you have these lobes that you see for the F orbital. But with a 5th level tetrahedron, there are now 3 protons that are not on the faces, they're in the center. And so again, just like D, they have strange shapes, and it can be explained because those are the ones that are not in alignment on a face, and they're in the center. And the interesting thing about this, we have to get smaller again, so now that proton is just going to be modeled in blue since we have to get much smaller, is that same sequence that explains the distances and the shapes of orbitals also explain the sequence of the periodic table of elements. And so first, helium mentioned that until boron, they were going to be 2-dimensional planar. And so you see linear and trigonal planar, and I'm using the same terms here as VSEPR technology, which explains molecule formation, until here neon, until it does a 3-dimensional structure. And again, it starts to build tetrahedral rows. And so the p orbital, or the p block here, is 6 protons. And that's a 3rd level tetrahedron. Now, adding a little bit more room, and with symmetry here, the D block has 10 protons. Well, lo and behold, that's the 4th level of a tetrahedron. And what is the F block? Well, the F block is a 5th level, tetrahedron. And an F block, or a 5th level tetrahedron has 15 units. And that's exactly what the F block has, 15 protons. And here's a model of what could be the arrangement, again, in a tetrahedral pattern for lutetium. And so all of it can be explained with the pentaquark structure of the proton, just an alignment of how all these protons build and create the distances, the shapes, and the unique structure of the periodic table of elements. And the cool thing about it, and this is finally what we can see visually, we can't see electrons nor protons and their shapes, nor even the atomic nuclei, but we can see molecules. And molecules are built from atoms that share electrons, such as carbon. And here's the 1s in there, and then you see the 2nd orbital. And the 2nd orbital now is not planar. Try to draw this out so it looks like a tetrahedron again, and that's because if you look at the valence electrons, the 2nd orbital, they would have to be separated out in a 3D structure as far as possible from each other. Right, and so what would that shape would be? Well, of course, it would be a tetrahedron again. And this is shown as carbon requires, for hydrogen molecules to really complete this, that is CH4. And CH4 is a tetrahedral formation. But there are other ones, linear and trigonal planar, and all of these are really just following the same nuclei pattern geometry of the valence electrons. So again, everything builds on itself, starting from the smallest one. And this is the summary. So everything that we see around us, all of matter, is formed from molecules, right, made from atoms, constructed of particles like the proton, and then here back to the electron. All this was shown in this section to be created from a fundamental particle. And that motion was governed by a fundamental force, only one rule, to move in the direction of minimal wave amplitude. And shown here is a standing wave where the minimal wave amplitude is the node. And that's it. And if that seems simple, it's because it is. The entire definition is shown here and compared to the prevailing theory, which is string theory in the Standard Model. Right? It only required 2 elementary particles, one that moved energy forward and one that reflected backwards. It only requires the 4 dimensions, the 3 spatial dimensions in time that we know today. And only required, this is the key thing, 5 theory constants, not 19. Didn't require strange explanations like parallel universes. So not only is it simple in its definition, but I think this is the most amazing part, is it's simple in terms of mathematics. Everything that you see here, everything in the videos can be downloaded from a website. Almost everything was put into a spreadsheet, and the equations could be modeled in a simple spreadsheet. The exception is the atomic orbitals. And also on the left is the derivation of how everything starts with that simple energy wave equation, derives particle energy, derives photon energy, and then also from there derive the equations for the forces. On the right side, it's compared to the standard model, which is a very complicated equation. Certainly not simple, but it's also worth noting that it has 19 adjustable parameters. And that was the simplicity, and now lastly, the proof. Now in the first 8 videos, and a lot more detail in the book series, or you can want to go all the way back to the technical papers, this is the following that was presented as proof. Either derived equations or calculations that match experimental data, and a lot of it. And also logical explanations that were explained and illustrated as shown earlier. And so a lot of proof, nearly all of which was mathematical. But a good theory not only explains and matches equations to existing data, but a good theory would also provide future experiments that could validate the theory. And here they are. There's at least 5, if not there's probably more. And my favorite is probably the first one. Right? The wave center fundamental particle rest energy was calculated to be 2.39 electron volts. Now, I spent a lot of time scouring through the neutrino experiments and will continue to do so. I wish I could build my own neutrino experiment, but these are incredibly expensive. But the neutrino, if the neutrino is found to be around 2.39 electron volts, that could be one way. And you can see additional experiments that are proposed. So there it is, a theory that is logical, it's simple, and provides a lot of proof. A simpler definition of the universe, the creation of particles and photons, and the motion of those particles known as forces. The question is this: where do we go next? And what do we do with this information? And I'm going to leave that question up to all of you, but I will say this. We inherited a great planet, and there's going to be many generations that will follow us. So let's leave them in a better position, and let's make the world a better place for the future generations to follow.